Hi everyone, welcome to Cognify. In today's session, we'll be solving for x. So we've got a few questions that we're going to be looking at. So let's tackle them one at a time. So in the first question, we are given x minus a and x plus b. Okay. So now here we are required to solve for x. So the solution we get here is going to have to be in terms of a and b. Yeah. So what's given here is two factors, which simplifies it for us. So we're going to take each of these factors and equate it to 0. So for the first one here, we'll have x minus a, equate that to 0. For the next one here, we've got x plus b, and then we equate that to 0 as well. So now here, we want x to be alone, right? So we're going to take a and then transpose it to the other side. So anytime you're transposing, the sign changes. So what we're going to have here is x is equal to positive a. On the left-hand side, it was a negative. On the right-hand side is positive. And then the next step is to solve for the next bit, right? So here we're going to transpose b to the other side, just as we've done with the previous one. So when we transpose, what do we get? X is equal to negative b. So these terms here, a and b, they are just some constant value. Could be anything, right? We can set it up ourselves if we want. But it's just a representation of some number. So that is the first one, right? Now, let us move to the next question. So in the next question, we are given 2 to the power of x plus 2 to the power of x minus 1, and then we equate that to 12. So what are we going to do here, right? So we can clearly see here on the left-hand side, these two here, they've got a common term. We just need to break it. We just need to break the second part, right? So that it looks like it. So we'll have 2x, right? That will leave it as it is because we can't break it any further. And then the next one, 2x, 2 to the power of x minus 1. So that one you can write it as 2 to the power of x multiplied by 2 to the power of minus 1. You see in the exponent here, we've got x minus 1, right? So that x minus 1 can be separated. So we can clearly see here there's a common term, right? It's these two here. So that we can factorize or remove from our expression here and just put it outside a bracket. So we're going to have 2 to the power of x, right? Since it's common. And then in its place, we're going to put a 1. Because if we go in the reverse order, we'll have 2 times 1, which gives us 2 to the power of x. Next part, plus. Okay, so we're removing 2 to the power of x from this one here, right? So what's going to remain? It has to be 2 to the power of minus 1, which is a half. Okay, so I'm just going to put it here for those that might be confused. Okay, 2 to the power of minus 1 is a half. So now we have that, right? And then we equate it to 12. So now let us simplify this. So we're going to have 2 to the power of x. Okay, and then inside here we'll have 3 over 2, which was equal to 12. Okay then, so now the next part we can see here is we can actually divide both sides, right? By this part here, 3 over 2. Okay, so that way it's gonna cancel it from the left hand side. So the way to do that, right, is we're gonna multiply this side by not 3 over 2, but the opposite, right? It's gonna be 2 over 3. Okay, so the reciprocal. So what we do on the left side, we do the same on the right. Okay, so it's going to be 2 over 3. What you'll notice here is that this 2 will cancel with that, that will cancel with that. So at the end, we're just going to have a 1. And then here, this 3, okay, goes into 12 4 times. Okay, so what we're going to have left here on the right hand side is 8. So at the end, this is what would have, right? 2 to the power of x is equal to 8. But the right hand side, we can write it as 2 to the power of 3. Okay, so since the bases are the same, okay, this part here, the base is the same, we can just equate the exponents. So it's going to be x is equal to 3. And that is basically it. Okay, so test this answer out and see if we are correct. Okay, and I'll leave that to you. So now the next part, in the next question, we have, let us move this some, we'll just put it here so it's clearly visible. Okay, so next question is 3.2. So in question 3.2, we are required to solve for x and represent our answer on a number line. Okay, so if x is a, let's see, what else are we given? Okay, we are given 2 times 2x minus 3 minus 18 greater equal to 2x. Okay then, so let us see here. So let us write it down, right? So we have 2 times 2x minus 3 minus 18 greater equal to 2x. So here we are given an inequality. Okay, we want to solve for x. Okay, and our answer has to be on a number line. Okay then, so let us see how we can go about doing this. So firstly, let us multiply the terms out. Alright, so we have 4x squared minus 6 minus 18 greater equal to 2x. Okay, so now let me quickly fix this here. So it's actually 4x. Okay then, so the next part here, we're just gonna transpose everything to one side, add up the like terms, right? So in this case here, we're just gonna take, let's see here, right? We can take these two here, put it on one side, and these two here, we'll put it on the same side. So let us quickly do that. We'll have 4x minus 2x. So I took the 2x transposed to the other side, greater equal to 18 plus 6. Okay. So now let us rewrite this. So it's going to be 2x greater equal to 24. So now here we can divide both sides by 2, right? So we'll have x greater equal to 12. So what does this tell us? That this inequality expression, this given expression, right? This relationship is only valid, okay, where x is greater or equal to 12. So now if we were to represent this on a number line, okay, how would we do that? So let us see here. Let's quickly just draw a line. Okay, so this will be our line. Okay, let us return for color. Okay, so now this is our number line. And on this number line, let us see here. Let's say 0 starts somewhere here. So 0 is here, and then let us increment as we go to the right. Let's say 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. So I think this part here we can just extend it from you to the right. So now we want to represent this on a number line, right? So x greater equal to 12. So let's see here. So if we check here, where is 12? It's here, right? So now we're going to be, let's just put a dot here, right? Or a circle at that particular point. Okay, so an open circle will only apply for cases where x is strictly greater than 12. But in this case here, we are setting another condition. It's also equal to 12. Okay, so what we do here, we're just gonna color it in, right? That way we indicating that the 12 is included, and then you just throw an arrow to the right. Okay, and it's indefinite, so there's no limit to it. Okay, unless there was another restriction here, right, where we'd say x greater equal to 12. Okay, and another condition would be, let's say, x less than equal to 20. Okay, and then you will put a restriction there. But that is basically it for this question. Okay, so let us continue. Okay, and the next part and the next question, we want to solve for x and y simultaneously. So to do this, right, let us see what we are given. So we are given check here, right? So if we look at what we are given, we are given two equations. The first equation is 2x plus y minus, equal to 6. So, okay, we'll define that as equation 1. And then the next one is 4x plus 3y is equal to 10. This will define it as equation 2. Okay, so now let's take equation 1 and write it in terms of y. Okay, what that means for this equation 1, right, I'm going to transpose this to the other side and just get y low. So y is equal to 6 minus 2x. The reason we are doing that is because from this, right, we will define this as equation 3. We're going to take that equation and substitute it into equation 2 because it has y as well. Okay, so what we are basically doing here, right, in this operation, we are solving for x and y so that we get the points of intersection where these two functions are meeting. Okay, so now this is equation 3, right? So we're going to take equation 3 and substitute it into equation 2. So it's going to be 4x plus 3, right? So this is where we substitute this part here, right? There. So this is going to be 6 minus 2x. Okay. And then let's see. So we've got that. And what else is left? And then we equate it to 10. So now here we can just multiply the terms out and then solve for x, right? So we'll have 4x plus 3 times 6 is 18 minus 3 times minus 2 is minus 6x. Let's just write it like that. And then what we're going to do here Since our x is in, we can actually simplify that. We'll just take the 18, transpose it to the other side. Okay. So now what are we gonna have? We're gonna add up these like terms. So it's gonna be minus 2x equals 10 minus 80. Okay. 10 minus 80, which is equal to minus 8. So now here we have minus 2x is equal to minus 8. Both sides are negative, so we can just divide it by -1. Because then we have 2x is equal to 8. I'm doing this step by step so that you understand each and every part of the process well. So our solution here is what? X is equal to 4. So now we got our solution, right? But that's only one part to it. The next part is to find the corresponding y. So what we're gonna do, right? This here, let's call it equation 4, right? So we're gonna take equation 4, and if we go up here, you remember we had defined equation 3 in terms of y. We can use this to find y. Okay, so we take this part here, right? So we take equation 4, substitute into equation 3. So what do we get here? We know that y is equal to 6 minus 2x. The solution we got was 4. So now here we have 6 minus 8, and this is equal to minus 2. And that is basically it, okay? So now we've got our two solutions for x and for y. So you can confirm these two solutions by substituting it and confirming. So when you substitute, for example, if you substitute it into these two here, right? Whatever values you put, if you put, for example, we'll put minus, what was it? X is 4 and y is minus 2. Here you put x is 4 and here you put y is minus 2. We expect to get these, what is it? These solutions are 6 and 10. If not, then we must have made a mistake. But I'll leave that to you guys to confirm. And yeah, that's about it. Thanks for joining this session, and till next time.